Okay, hello students. This is the last and final topic of the chapter matrices, and the last subtopic, the third part, the last part of the chapter is multiplying two matrices, as you can see on the in the screen. Okay, so let us go with the rule of multiplying two matrices. So two matrices can be multiplied if and only if the number of column of the first matrix is equals to number of rows of the second matrix. This is the first rule. So okay, as you can see, the definition goes that, or the rule goes, assume that matrix A is of the order m cross n and matrix B is the order p cross q. Okay, so we can multiply the two matrices if and if, as you can see, the column of the first matrix should be equals to the number of rows of the second matrix. That's a rule to multiply two matrices. That means if this is satisfied, these two are equal. If I say that the value of n is equals to value of p, then in that case we say that the two can be multiplied, matrices can be multiplied. Okay, let us see one example to the same. It becomes more clear what I mean to say. Okay, here you have example. Here this matrix here is of the order 3 cross 2, and this matrix here is the order 2 cross 3. You know why now? Because in this first case, okay, in the first case there are total 3 rows, 2 columns, and in this case there are 2 rows and 3 columns. So these two matrices, this matrix and this matrix, can be multiplied because the column number of the first matrix is equals to number of rows of the second matrix. Then only we can go ahead with multiplication. Okay, so that is important to understand. Okay, so now let us see an example of multiplication which is there on the other side of the screen. Okay, and let us understand it very nicely, because if you happen to understand the concept, okay, the detailed part of the concept, then things become more clear. Okay, I have zoomed it for you all so you can understand better now. Now let me point out certain things. You also take your notebook, your rough book, paper and pen in your hand, and you copy these two matrices, that is this matrix and this matrix. Okay, so because if you don't write it, if you don't practice it, if you don't put it on the paper, this multiplication concept is difficult to understand. Okay, which number goes to which number. Okay, so first of all, if you can tell me, and if you can tell me that what is the order of the first matrix. So there are how many rows? There are 2 rows, and there are how many columns in the first case? There are 3 columns, right? Fine. What about the second one? This one. So here there are 3 rows and there are 2 columns. Is that clear? But what is important part to note now, that the number of columns of the first matrix is equals to the number of rows of the second matrix. So the rule says, you can multiply two matrices only when the column number of the first matrix is equal to the row number of the second matrix. Fine, so we can multiply. Now try to get this. Now when two matrices, as you can see here, these two matrices are multiplied, this one and this one multiplied, you get this matrix. This is called the product of the two matrices. This one is called the product of the two matrices. Fine, this is called the product of the two matrices. How you get the product of two matrices, very important to understand. Also in this is also called the dot product. This so formed is called the dot product of, this is the dot product of these two matrices multiplied. Therefore you can see there's a dot given there, it's also called dot product. Okay, Fine. Now let us come to the detailing of this concept, that is how you get the dot product of when two matrices are multiplied. Okay, now first get this, why the rule says this way, that number of column and the number of rows of the two matrices should be equal, because as I tell you the rule, as I unfold the rule to you, you understand better why it is given that way. Okay, so you can see here that the so formed matrix, that is the given one, in this case, okay, in this case, if you tell me the order of this matrix is 2 cross 2, this 2 cross 2, and you can also think this way, that when two matrices are multiplied, then the resultant matrix so formed will have order, where the number of rows will be 2, as you can see here, and the number of columns will be this 2. Understood? Okay, so this is also one rule, that when two matrices are multiplied, then the resultant matrix, the product one so formed, will have the order 2 cross 2, that is the row number of the first matrix to the column number of the second matrix. Okay, so there will be 4 elements formed. Fine. So how to get the 4 elements now? Okay, so let us see each number, 44, 72, 37 and 73, how they are formed. So let us see this. Always tell yourself row into column. This is what you have to repeat and tell yourself, row into column. Okay, then next you say the elements of the row multiplied to the corresponding elements of the column. The elements of the row multiplied to the corresponding elements of the column. That means in the row 4 is the first one, in this column 3 is the first one, in this row 2 is the second one, in this column 2 is the second one, in this row 4 is the third number, in this column 7 is the third number. So you have to multiply it to that rank. 4 goes to 3, 2 goes to 2 and 4 goes to 7. So if you see properly now what I have done, okay, I am marking for you all. So this 4 goes to this 3, first goes to first, right? Okay, now this 2 goes to this 2, you can see here, and this 4 goes to this 7, and then you have a plus sign between all these numbers so formed. So when you multiply and then you add these numbers, you get 44. Now to understand this 44 is the first element what you see here. Is that clear? So multiplying the first row with the first column gives you the first element, and you can see this element is of what position. It is the first element of the row and the first element of the column. Okay, his address you can write here. The address of this element is 44 is 1 cross 1. That means first row multiplied to first column. All the elements of the first row multiplied to the first column. So the address of this element is 1 cross 1. Right now this 72, that is the second element here, 72. If you can guess the address of this element, is actually the second element of the, that is first row second column. It is first row cross second column. Right now it is from the first row and second column, right? So it is, that is, this 72 is on the first row. This is the first row, and it is on the second column. So the address is 1 cross 2. So when I say 1 cross 2, it is you are multiplying the first row, multiplying the first row, as the address says, first row, into the second column. So first row second column. So first row second column. So 4 into 5 here, 2 into 8 is here, 4 into 9 is here, and then you multiply and you write, and you add and you write the answer 72. So this 72 position is 1 cross 2, that is, okay, it is first row, second column. So can you guess for 37 now what is the address? The address for 37 is second row, first column. So it is second row, first column. So as the number says second row, means you have to multiply the elements of the second row with the first column. Second row with the first column. So it is very simple. Now you understand. It is 8 into 3, 24 here. Okay. Then 3 into 2, 6. Then 1 into 7. Okay. So multiplying and adding, you get 37. Okay, same way now you can guess how to get 73. So 73 is actually the fourth fourth number in that case, fourth element. But what is the address? It is in the second row, and also it is in the second column, the address of that element. So that means it is giving you the hint that you have to multiply the second row with the second column. So 8 into 5, just a minute. Okay, so it is 8 into 5, then it is 3 into 8, and this is 1 into 9, so 1 into 9. Okay, is that clear? 73, and then this is your number. So the more you will again rewind and play the video, and from your side if you practice then without seeing, this will drill you in this topic, multiplying two matrices. If you want to make it more strong and if you want to have a good hang on this topic, it's by only practicing. The more you practice by taking different types of matrices, that is the different types of matrices, and I say the order, different orders, and you multiply, and then you can get a strong hold on this. The only thing, avoid silly mistakes, that is multiplying silly mistakes, and very important is to understand the address of each element. Understand the address of each element, which is very, very important. Understand the address of each element. This is the address of each element. That is this 44 is address is 1 cross 1. That is first row, first column. 72 is first row, second column. 37 is second row, first column, and this 73 is second row, second column. Is that clear? So you get a hint what to do when you multiply. Now this becomes more clear when I take the next page, and here this is the questions from the textbook, and I've taken the next exercise, that is the third exercise, that is 9C now, and here you can see this element, that is this matrix, that is 3, 3, 2 and 2, 0 are to be multiplied. Now if you see properly, okay, what is the order of the first one? The order of the first one is there is one row and there is 2 columns. Is that clear? This is the order of the first matrix. What is the order of the second matrix? The order of the second matrix, there are 2 rows and there is one only column. Is that clear? And with the rule says, as the rule says, that I can multiply because these numbers are same. Yes or no? I can multiply. But what is important to understand, that when you multiply two matrices, okay, two matrix, when you multiply two matrix, okay, the resultant matrix so formed, the dot product, will have the order as, can you tell me, will have the order as 1 cross 1. When I say 1 cross 1, that means 1 column 1 row, 1 column 1 row, 1 column 1 row. That means it will have only one element. That is important to understand. That means 1 cross 1 means 1 column, 1 row and 1 column. That means the matrix that will be formed will have only one element. That is make it more clear. So I want a matrix, okay, of the order 1 cross 1. That is what is expected, 1 cross 1. Okay, so that means I go to my question. My question is, I have to multiply this two matrix, and then I have to go to the answer part. Okay, I need to multiply the first row with the first column. So 3 2s are 6, and then 2 into 0 is 0. With what sign middle? I said the plus sign will come in middle, and after you add these two numbers you get 6. So 6 is what is the answer, and 6 is the only element. 6 is the only element in this matrix. Is that clear? Okay, now let us make things more clear. Now I have purposely you can see given you more practice should be required. So I have taken one more example here to make things clear. And now what you can do, you don't see the solution, you try from by pausing the video and then see my explanation. Is it matching with your solution or not? Okay, so pause it, take up the question, pause the video, and you multiply from your side. Okay, so let me start now. So here we see that this matrix is having the order 2 cross 2, and this is having 2 cross 1. Yes or no? So now what you understand from this, that the two matrices can be multiplied. Yes or no? The two matrices can be multiplied. That is what is important. Okay, now the resultant matrix will be of what order? The resultant matrix will be of the order 2 cross 1. That means there will be 2 rows and 1 column. There will be 2 rows and 1 column. Get this understanding very clear. The resultant matrix will have 2 rows and 1 column. So when you think that way, try to get it. So you make a matrix roughly from your side. This is your rough work. You have to make a rough work. So there should be 2 rows. So you make box here, 2 rows. So this is what I have done actually. So I have shown you this is a matrix of the order 2 cross 1 because there are 2 rows and 1 column. Understood? So your answer matrix, that is a dot product matrix, should look like this right now. So in that case, tell me students, the first box, what is the address of the first box? Okay, so the address of the first box is first row cross first column. So you come back to this part. So first row first column, am I right? First row first column. So 6 into -1 -6, and 4 into 3 is 12. Is this clear? Okay, so what you see here, 6 into -1 is -6, that is 6 into -1 is -6, and 4 into 3 is 12. So this what you get is basically, if you happen to do the operation, this 6 actually comes where? This 6 is here. Is that clear? This is 6 here. Now for this, can you tell me the address of this box? So the address for this one is, this is the second row and first column. So you have to multiply. So that means if you want the answer for this box, you have to multiply the second row with the first column. Second row, first column. So 3 into -1 is -3. 3 into -1 is -3, and -1 into 3 is -3. And you do the operation, you get -6. So this -6, what you see here, that is -6 is the answer. -6 is the answer. Is that clear? So this is what is multiplying two matrices. Okay children, so here you can hide, you can pause the video, take up the question, and you solve this matrix what I have given you, and the order of this matrix is 2 cross 2, and the order of this matrix is also 2 cross 2, 2 cross 2, and I can multiply because now I think so you're getting used to this definition, that this rule that you can multiply because the number of column of the first row is equals to number of rows of the second matrix. Is that clear? And the resultant matrix, I think so you now know the resultant matrix will be of what order? 2 and 2, that is 2 rows and 2 columns. Is that clear? So you can see also here the answer what I am getting is also having the same matrix, that is 2 cross 2. Is that clear? 2 cross 2. Okay. Okay students, so what I'll do, I'll come with the next video where I solve many sums of the same topic or the same subtopic. Okay, you can also try from your side and come up with many difficulties as such, but keep on solving. The more you solve, okay, the more better you get. Okay, let me share with you before I close the session for now. Let me share with you some properties of both addition as well as multiplication. Okay, so when you happen to add two matrix, okay, the first one here, the first rule here, so you can do, they are commutative, that means the addition of a plus b is as well as b plus a. Okay, but tell you one very important thing, this doesn't hold good for multiplication. That means when I multiply a multiply to b is not equal to b multiplied by a. You can try this. A cross b is not equals to b cross a. Okay, this doesn't hold good for properties of multiplication of two matrices, but it is a true rule for addition of two matrices, that is a plus b is equals to b plus a. Also addition of matrices follows the associative rule. You can see here in this case, that is a plus bracket b plus c as well as a plus b bracket plus c. It follows the associative rule. Okay, so so also when you a plus a null matrix is a, so it is an additive identity, you know, and if you add a plus b and it is null matrix, then b is actually the additive inverse of a. We have discussed this before, so we have done sums based on this topic, which is a plus b is 0, then b becomes the additive inverse of a. Okay, so see, if you see the matrix multiplication property here, it follows the associative rule. That means if three matrices are to be multiplied, so you can multiply b into c first, and if you multiply a, the answer is same as if you multiply a into b first and then multiply c to it. Okay, also it follows the distributive rule, that is if you add b plus c, the two matrices, and then add to a, is as good as multiplying ab and ac and then adding it together. So it follows the distributive rule also. Okay, fine. A here, c here, same concept. Okay, fine. Also, if you multiply an unit matrix to a given matrix, you get the matrix back. Unit matrix, I think so you understand, that is the diagonal is having 1, others number are 0. Okay, so practice hard, and I'll see you in the last session. Okay, thank you.